All right, let's talk about machine learning. Now, you might think teaching a computer is all one size fits all, but it's really not. In fact, think about how you and your friends study for an exam. Some of you have color-coded notes weeks in advance, and others, well, you work best under pressure, right? Today, we're going to dive into two major strategies that mirror that exactly: eager versus lazy learning.
So, let's just get it out there. Be honest with yourself. Which one are you? Are you the prep master, the one who's ready for the final a month before it happens? Or are you the procrastinator, the one doing some, let's call it just-in-time learning, an hour before the test? Because believe it or not, your answer tells you a lot about these two really powerful and really different approaches in machine learning.
Okay, first up, let's talk about our prep master. We're going to call this the eager student strategy. This is the person who goes to every class, synthesizes all the notes, and builds the ultimate study guide way before the exam. Their goal? To have an answer ready for literally any question the professor could possibly throw at them.
Their whole philosophy is do the work now, relax later. In machine learning terms, they take all the training data, every single example, every data point, and they work like crazy to build one single, solid model. They're not just memorizing, they're trying to figure out the underlying rules of the subject. The goal is to create this generalized function so that when test time comes, bam, the answer's just there, no thinking required.
And this maps perfectly to the technical definition. Eager learning algorithms build their model based on the entire training set right from the start. The key phrase to remember is before they even see a new query. They commit to creating one single global model that tries to explain the whole data set in one go.
So the process looks something like this. Step 1 is that intense all-night study session. You're building your big, comprehensive model. Then, step 2. Once that beautiful study guide is finished, you can kind of toss the messy original notes. The knowledge is now in the model. And that leads to the big payoff in step 3. When a new question, a new piece of data comes in, the prediction is lightning fast. The answer is ready to go.
And you've definitely run into these eager learners in your courses. A decision tree is a perfect example. It has to build that whole complex tree of if this, then that rules up front. Neural networks that learn through backpropagation are the same. All that heavy training happens first. They all put in the hard work early so they can be super fast later on.
Okay, now let's flip the script completely and meet our second character. This is the lazy learner. Now, we call him the procrastinator, but maybe a better word is efficient? Their whole philosophy is, why study everything when you don't even know what's going to be on the test? They're all about that just-in-time approach.
This quote from the source material just nails it. Lazy learning methods basically postpone any real thinking. They don't bother building a big, fancy model ahead of time. All the real computational work is deferred until the very last moment, when someone actually asks for a prediction.
And their process is the polar opposite of the eager learner. Step 1 is a breeze. You just store the data. It's like downloading all the lecture notes into a folder and calling it a day. You don't even read them. Step 2 is also pretty easy. You just wait. Then comes step 3. The test question arrives. Now the work starts. The algorithm frantically searches through all those stored notes to find the most similar problems it's seen before and calculates an answer right there on the spot.
And this image shows you exactly how it works. This is the classic lazy algorithm, k-nearest neighbors, or KNN. To figure out what that new red point is, it doesn't consult some big pre-made rulebook. No way! Instead, it literally just looks around at its closest neighbors in the data it's stored. In this case, it looks at its 5 nearest neighbors, sees that 3 are pluses and 2 are minuses, and a little vote happens. The pluses win. So it predicts the new point is a plus. All of that computation, that whole voting process, happened just now. Only because we asked.
Okay, so we've met our two rival students, the prep master and the procrastinator. Both of them can get you the right answer, but their methods, their costs, and their benefits are worlds apart. So let's put them head to head and see the real differences.
This table lays out the trade-offs perfectly. First, training time. The eager learner is slow and needs a lot of computational power up front. The lazy learner, training is a joke. It's basically instant. You just save the data. But then, look at prediction time. The roles completely reverse. The eager learner is fast, while the lazy learner is slow because it's finally doing all the work. Here's another key difference. The eager learner builds one single global model for everything. The lazy learner creates tiny local models on the fly for each specific question. And that leads to a huge practical difference with new data. A lazy learner just adds the new data point to its memory. Easy peasy. The poor eager learner, you got to retrain the whole thing from scratch.
Which brings us to the ultimate question, right? After all that, which student is actually better? You've got the meticulous planner who's prepared for anything, and you've got the adaptable genius who thinks on their feet. Which one do you actually want to hire for your project?
And the classic engineering answer is, it totally depends on the problem you're trying to solve. You're going to hire the eager student when you absolutely need lightning-fast predictions and your data isn't changing all the time. But you're going to go with the lazy student when your data is constantly evolving, or when the problem is so complex that one single global model just can't capture all the nuances. That ability to make local, specific decisions is the lazy learner's superpower.
So I'll leave you with this final thought. Think about building a movie recommendation system versus building the control system for a self-driving car. Which student would you hire for each job? And more importantly, why? Answering that question, well, that's when you really start to understand the power and purpose behind these two brilliant rival strategies. Thanks for checking out this explainer.